Hello class, in this video I want to walk you through how to name polyatomic compounds. Those that have more than two elements when they combine together to make a compound. Poly means many, so we have more than two, and we're going to work with groups that have a set charge. Those polyatomic ion groups are found on the backside of your periodic table, so you can always use those, and they often have an 8 or ite ending. Some of them do not. Some of them have an ID ending, like hydroxide. You just have to memorize that that's a polyatomic ion. Or ammonium is another one that you just need to kind of memorize as a polyatomic. It does not have the same type of ending, but it is on the back of the periodic table for you. That is NH4 with a +1 charge. Ammonium is one of the few positive ions as well, so you'll see that come first. Just remember to identify it as a polyatomic ion, and we'll be all right. So here's a couple examples, and polyatomic ions also use charge, so we'll be using a positive or negative charge based on the polyatomic and the charge it has as a group. And when we take the formula and write the name, we're going to identify the polyatomic ion, in this case NH4 is ammonium, and write that name of the polyatomic ion first, and then whatever it's combining with or bonding with second. In this case it's a sulfur, so we'll change that to sulfide. Polyatomic ions can also hook onto the negative spot for a compound. So in this case, we have cobalt and sulfate. The 8 ending indicates that it's SO4, and each SO4 has a -2 charge. With one cobalt, that means the cobalt is using its +2. So we would say cobalt 2 sulfate. OH is another polyatomic ion, hydroxide. There are 3 of them. Each one is a -1. So the hydroxide must be, if there's 3 of them that need to balance it, that means iron must be carrying a +3 charge. So we have iron, Roman numeral 3, and then the polyatomic hydroxide. All right, taking a look at a couple of these examples. Sodium and carbonate, I'm looking at the ending. I see ATE, that's going to clue me into this is a polyatomic ion. Carbonate is CO3 with a -2 charge, and sodium is Na with a +1. Put those together, I need 2 sodiums for every 1 carbonate. Please really be aware of what these subscripts tell you with polyatomics. Each carbonate always has 3 oxygens, and it can't be carbonate without it. This does not mean that there are 3 carbonates in the compound. It simply means there is 1 carbonate. Each one has 3 oxygens. If I need more than one polyatomic ion group, I will put the entire group in parentheses, and the subscript number tells me how many groups I'm using in my compound. So when we take a look at the next example, iron 2 nitrate, each nitrate group has a -1 charge. The iron in this case is +2, therefore I need 2 groups, so I'll put the whole group in parentheses and the 2 outside. All right, so that's basically how you would write the formula from a name for polyatomics, looking at the name that's given, and then going back to decide if it's what the charges are and balancing those out. Notice if the ending is IDE, we're going to use the same binary ionic rules that we had before. This is just copper with a +1 charge and sulfur. So we have Cu2S. No sulfate here. It's a different ending. So kind of be careful with those as we go through it. Again, if we're going to be writing the name from the formula, identify the polyatomic ion first. In this case, phosphate is highlighted in green. There are 2 phosphates and there are 3 zincs. So the charge of zinc is always a +2. We don't need a Roman numeral for that, but we do need to have 3 of them in this compound in order to balance the charges and have a compound work with ionic charge. All right, so if we take a look at the second one, the polyatomic here is carbonate. CO3 with a -2, sodium has a +1. When I write the name, I'm just going to simply list the name of the metal first and the name of the polyatomic ion, carbonate, ATE ending. Okay, and I'm done. If I have a multivalent metal, I need to include the Roman numerals in the name. So when I look at this next one, I have NO2, okay, and an NO2 is going to be a nitrite, and we're combining that with copper. Well, I need to go back and figure out what the charge of that copper is. So an NO2 always has a -1 charge. Nitrite has a -1 charge. Since there's two of them, I have a total of -2 on this side. With one copper, that means this must be a +2. So this copper ion is a +2. It's using that in this compound, so I'll put it in the name. Roman numeral 2 is a +2 copper, and we're using nitrite, ITE ending. So be careful with the eights and the ites. All right, double check your work on this, and please reach out if you have any questions. Thanks.